Away from J3 hat. All right, and now down here, since we have positive going this way, I recommend making that positive. And we can just put a plus sign because this is a one-dimensional problem down here, or we can give it a label called I2 hat. All right, so we've gotten the ACA. Now we're down to D.
Wait, only there's no I and J.
We
So
could,
J is just the same way as the top part?
we could have J2 hat going this way or that way, but there are no forces in that
Correct.
direction, so it would just be for the fun of it.
Okay, okay.
Officially, the equation would be 0 equals 0, which is a true statement,
0 equals 0.
I believe.
I'll write that down.
Decomposition.
What do we have to decompose anything?
Weak. Free.
Yep. I have, well, these are all fine. Looking at my 3 kilogram mass there and finding a blue marker that might make marks. Those are the forces we care about. Only one of them is not parallel or perpendicular or anti-parallel to one of those. So we have to bring weight up. And, all right, so that one's going to stay as is, about 3 kilogram mass. I've got y sub 3 going this way. I have friction going that way. I have tension going that way. And my weight is going to be broken up. So, what's what?
This one is
So you're saying this one is sine and that one's cosine?
yes.
It depends, but I think you're looking at that backwards from this. Because whenever I drew the ramps in the past, I think I had the ramps going this way.
Yeah.
Oh, yeah,
No, I have it going that way.
So it would be the opposite.
Yeah, the one down the ramp is going to be sine. Sine of what, though?
Oh, not.
Pardon?
Sine of theta or something?
What's theta?
We use this software.
Theta prime.
The sine of, if you do sine of 130, no, I don't think that's going to work. Cosine of 130 get you a negative number, and that's really going to mess with your heads. So,
We just do 90 degrees minus, or 130 minus 90 degrees gives us that top angle.
yeah, that's what we want right there.
Okay, great.
So that is 40 degrees. So we'll be sine and cosine of 40 degrees. So this will be, so this is W times the sine of 40 degrees, and we'll just call 40 degrees theta. And this will be W cosine of theta.
How did we get 40 degrees?
This whole angle here is, I said it was 130, that was given in the problem.
Yeah.
I broke it up into a right triangle here and whatever's left over.
Okay.
So if that's 90, that's gotta be 40.
All right.
Decomposition done. Yeah, Pratika?
Can you explain how you got the cos and sine?
All right, so I have my that's my triangle right there, or my angle. That angle there I'm labeling as theta, which we know is 40 degrees. I'm breaking weight up. Weight is acting straight down. I need to break it up into part that is down the ramp and part that is perpendicular to the ramp. Weight is what I'm breaking up. That's my hypotenuse. If this angle here is theta, then this angle up here must be the complement. Because of looking at that triangle right there. So this is what I generally label as theta prime. this angle down here must be the complement of that angle, because that's a right triangle there, and got a smaller one. So that's theta. It's the complement of theta.
Okay.
Is that sufficient?
Yeah.
Now what? Bless you.
Thank you.
What comes after decomposition? Yes. What is the template? What's the base formula?
F equal MA.
Yep. How many equations will we have? How many equations of motion will we have?
2.
Why 2?
Because there's 2 masses. Because there's 2 objects.
You missed one thing. There are 2 objects, I agree with that. How many dimensions for each object?
Oh. So 4.
3,
Yeah.
because I had 2 and then I had
Yeah. This will have 2 equations, that'll have 1 equation. Unless you went through a 0 equals 0.
As you keep going, can you just dumb it down a lot? Because this is where I get confused when you make these equations.
Okay.
So just say everything you're writing down, please.
All
Where
right.
you're getting it from.
No problem.
everything.
All right.
Yes, like literally, like I'm
What?
in 5th grade.
Once we've established that there's 3 equations of motion,
Okay.
because this is a 2-dimensional problem, that's a 1-dimensional problem, 1 plus 2 equals 3. I'm gonna have an I 3 hat, a J 3 hat, and an I 2 hat equations. Those are my 3 equations right there. 1 for each coordinate axis. Now I look at what I have here. We'll take this one first, because why not? I'm going to put all the forces in the positive direction down first. What are all the forces in the positive direction?
W2.
Yeah, got 1 there. So W2. All right, now minus. What are all the ones in the negative direction? Equals.
F acceleration. Gravity. No.
Mass 2 is going to accelerate.
There's an acceleration I forgot to say.
Just MA.
One small issue.
Into
Yeah, we have 2 different masses here, so we need to we're going to differentiate at some point, so M2A. It does have the same acceleration as the 3 kilogram mass, so A will be the same for both.
How did we come up with that? That the acceleration is going to be the same?
Ideal rope. It's not stretching, it maintains its length, so however far the 3 kilogram mass moves, the 2 kilogram mass will move the same distance, because the rope does not stretch.
How does distance relate to acceleration?
If the forces are constant, acceleration is constant. If acceleration is constant, we have arcade formulas. That would be the relationship.
So you would always put the one that's going in the positive direction first minus the one that's going in the negative direction?
I try to.
Okay. Would it matter?
No, if you want to do negative FT plus W2,
Okay.
that's fine.
That makes sense.
Bless you. If you want to do FT minus W2, then you probably should have picked the other direction for the positive direction. All right, so the next one. Let's do J3 next. I've only J3 is this way. I guess J3 is that way, that's negative J3. What are all the forces in the positive J3 direction?
Normal force. Y.
Tension.
Minus? Tension is not J3, that's I3.
Weight cosine theta equals mass 3 times 0.
Yep.
Wait. Can you remind me why I gave it 0?
Which way is it accelerating?
Okay, I remember.
Oh, okay.
Thank you.
No, keep going.
That's what I'm asking.
We've established that if the acceleration is down the ramp.
Yeah.
It's not going to accelerate off the ramp. The thing is not going to mysteriously start floating off the ramp, and it's not going to dig into the ramp. So the acceleration is down the ramp, which means that the acceleration is not perpendicular to that. Once we have the direction of acceleration, I know perpendicular to that, the acceleration is 0. We did the same thing in projectile motion, but we disguised it a little bit. I know that once the ball is in the air in projectile motion, the force is downwards. So I know that in the horizontal to that, or perpendicular to that, which is horizontal, the acceleration is 0. Abigail?
And we got the W cosine theta because it's the opposite direction on the decomposition
Yes.
of the, okay, that makes more sense.
Yes. And just rewriting that
Okay.
so that it's closer. We had established down the ramp, that was our I3 direction, and away from the ramp, our J3 direction. All right. Riley?
That's a quick question. So after you decompose W3, you don't need to put the subscript for W cosine and W sine?
Oh, you do.
Okay.
Sorry about that. So that would be W3 and W3. Means that's W3. Thank you. That would come back to bite us in the end.
Would you count off for, like, on a test if we didn't put W3?
It depends on what the question was. If the question was, you know, if I just wanted you to get as far as the equations of motion, then yes, I would. If you actually needed to solve the problem like we're doing, then it's an intermediate step. If you correct it later, then no harm, no foul.
Like in the answer?
Yeah.
Okay.
Yeah.
So as long as it's like in the answer, like if you were to, if this wasn't like an answer to a problem, you wouldn't count off for not putting the 3s.
Right, but if you get the wrong answer, then I'm going back and trying to figure out where the mistake was, and if I can trace it back to there, then yeah, I would take off for it at that point.
Sure.
But if you get the correct answer in the end, on a test or quiz, I'd probably just say, oh, correct answer.
Okay.
On test corrections, though, I will be going through.
So like I saw your test for like building up a question. Like your answer from part A could be what you need for part B. So let's say you got part A wrong. Does that mean the whole question is wrong?
No, it means I'm working through the problem with your new answer.
Oh, okay.
I did have a test, it's one of my favorite tests. Rube Goldberg plays a note, and referred to as the Rube Goldberg test, where part B depended on A, C depended on B, and so forth, all the way down. There was only one answer that was somewhat independent of everything else, but in theory, if I looked at the last answer and saw that it was correct, then pretty good odds everything else was correct, except for that one offshoot. In that particular one, I said, if you don't know how to solve it, use this number in whatever the appropriate units are. And I gave a number in brackets at the end of the problem. And so that ended up being the easiest to grade because I had a spreadsheet with all the calculations, and oh, you got a 4 here instead of a 3, I type in a 4, and it tells me what all the rest of your answer should be. It was nice grading. From a grading point of view, it was not nice grading from an actual grades point of view. Yeah, that was a bit overwhelming, apparently. Anyway, I digress. I3?
But they're all in this,
They're all
the same direction, so.
Yeah.
they're all positive.
Yep, because we said I3 was positive that way, so it's F sub t plus F plus W sine theta minus 0 if you want. Pardon?
Oh, you're just putting it there.
Just for the sake of it, just emphasizing the fact that we take all the positives and we're subtracting all the negatives. I don't have negatives. Is equal to,
W what?
thank you very much, that should be a 3.
M3A.
Say it again.
M3A.
All right, we've gotten through E, just 2 more letters to go. What's left? What's next?
So is this when you combine the I3 and I2 or something like that?
Substitution next before we can start combining equations.
Wait, oh, and G?
All right, the end of the substitution. I know that W equals mg. So that was one that we'll make. And what's the other independent equation we have?
Friction.
Kinetic or static?
Static.
Kinetic.
And
Oh yes,
fight.
yes, kinetic because it's moving.
Yeah, it's already, oh, sorry. It's already moving.
Yeah.
We don't have to, we're not worried about, is it gonna move or not? It is moving, that's the problem. Now, the second part, will it slide back down? Then we have to worry about it, but right now, is it moving? Sorry, it is moving, so we're just using kinetic. So this is what we're plugging in. So my first equation now becomes Ft plus UK y plus M3G sine theta equals M3A. So did the substitution there for F, substitution for W. And taking the bold step of saying that subtracting 0 from that is the same as that. This equation here, I know my right-hand side is equal to 0. I know I'm going to eventually have to solve for y3. Oh, that should be a y3 there. So y3 equals m3g cosine theta. So I just did the substitution and brought this over to the right-hand side. And then the last one,
Wait, how'd you just bring it over? If that
I,
W equals mg, don't you have M3 twice?
no, what is that?
Oh, yeah, I know. Just making sure.
Okay. I appreciate that.
Thank you. See, I was confused.
And then the last one, I have only one substitution to make since friction's not in there. And so I have M2G minus the tension is equal to M2A. And again, these A's represent the same thing because of the beauty of that rope we're using. It's not stretching, their accelerations are the same. And now, solve.
Wait, but don't we substitute the y3 in the first equation with the second one?
Yep. So we pop that in here. I don't count that as part of substitution because when I say substitution, I mean we're substituting in formulas which are independent of the problem. Like that is it. That's the formula for weight. And that's the formula for kinetic friction. Those are formulas regardless of what problem we're working on. To me, this is part of the solving part. So we plug that into there. And, well, let's just pop over to a new screen here. So I have FT plus UK M3G cosine theta plus M3G sine theta is equal to M3A, and M2G minus tension is equal to M2A. I think that is correct based upon memory and what we have written over there. Laura?
Okay, so my question is, at this point, we can't cancel out mass because FT doesn't have a mass
Correct.
with it. So do we now have to plug in whatever FT?
We don't know what FT is.
FT could be M2A minus M2G.
Okay, we could, yeah, it depends on how we want to get rid of FT. Our unknowns are FT and A. Those are, we have two unknowns, we have two equations. Life is beautiful that way. Two independent equations. Or not completely dependent. So we could solve for FT here, plug into that, or solve for FT there, plug into this, or just add the equations. I add the left-hand sides and add the right-hand sides.
So where did the Y3 go?
Y3 from this equation right here, we had that Y3, found that Y3 is equal to M3G cosine theta. Because there's no acceleration in this direction,
Right.
those have to balance out. So the magnitude of this has to equal the magnitude of that. And W equals mg, that's where the mg comes from. Add the equations straight up or solve for FT and then plug into the other.